Welcome to the deep dive. Today we're venturing into some really mind-bending territory. You know how we often talk about health hacks and optimizing our
You
experience?
only finding those little tweaks.
Exactly. Well, what if the very fabric of our reality? What if it isn't quite what it seems? We've been digging into the double slit experiment, and honestly, it's making us wonder, are we living in, like, a partially rendered universe?
Huh, that's quite a leap.
A bit like a video game, you know,
Yeah.
where only what you're looking at is fully loaded.
It's definitely a provocative starting point. And the double slit experiment, I mean, it's not directly about simulation theory, obviously, but it definitely gives you a fascinating lens to, well, question your assumptions about reality.
Okay, so walk us through it, the basics.
Right. So at its core, it involves firing something light, electrons, whatever, at a screen, but there's a barrier in between with two narrow slits in it.
Okay.
Now, if light was just, tiny particles like little bullets.
Like throwing tennis balls through two gaps in a fence.
Exactly. You'd expect to see just two bright bands on the screen behind the slits. Two piles of tennis balls? Simple.
Makes sense. But that's not what happens, is it?
Not at all. What you actually get is this interference pattern, a whole series of light and dark stripes spread out across the screen.
Stripes, like waves interfering.
Precisely. Like when ripples in water overlap, sometimes they add up, sometimes they cancel out. So light, which we often think of as particles, photons, it's acting like a wave. It seems to be going through both slits at the same time and interfering with itself.
Okay, hold on. How can one single photon go through two separate slits simultaneously? That doesn't compute.
Well, that's the first big mystery, isn't it? And it gets even stranger, believe it or not.
Oh, great. Go on.
So scientists thought, okay, maybe the photons are interacting with each other. Let's send them through one at a time, really slowly.
Okay, so just one photon goes through, hits the screen, then another, then another. That should just give you the two bands then, surely.
You'd think, but no. Over time, as you build up the impacts of those individual photons, one by one, that same interference pattern emerges again.
What? Even when they're going through alone?
Yep. It's as if each individual photon somehow is aware of both slits. It's interfering with itself. It's exploring both paths.
How is that even possible? It's like
Yeah.
it hasn't decided where it's going?
Sort of like it exists as a wave of possibilities, but then here comes the really big twist, the part that really messes with your head.
Okay, I'm braced.
What happens if we try to peek? If we try to actually see which slit the photon goes through? We can do that, right? Put a little detector by the slits.
Yeah, you'd think you could just measure it, find out which path it took.
You would think, but the instant you put a detector there to observe which slit the photon passes through, poof,
Right.
the interference pattern completely vanishes. Gone. Dead serious. Suddenly, the photon stops acting like a wave going through both slits. It behaves like a good old-fashioned particle again. It definitively goes through one slit or the other, and you get just those two distinct bands on the screen like we originally expected with the tennis balls.
So, just looking at it changes what it does.
It seems that way. The act of measurement, of observation, seems to fundamentally alter the outcome. It's like the universe knows we're watching.
Okay. Wow. So, how do physicists even begin to explain that? That leads us to the Copenhagen interpretation, right?
That's right. That was one of the first major attempts to make sense of this weirdness, mostly associated with Niels Bohr and Werner Heisenberg.
And the core idea there is.
The core idea is something called superposition. It suggests that before you measure it, a quantum entity, like a photon, doesn't have a definite state. It exists in a superposition of all its possible states simultaneously.
So, it's going through the left slit ND, the right slit ND, not going through either all at once. Kind of.
Kind of, yes. It exists as a wave of probabilities, but the active measurement forces it to, well, collapse that wave function. It has to choose one state, one definite reality.
So, the observation makes it pick a slit.
In the Copenhagen view, yes. Reality at that level is fundamentally probabilistic, fuzzy, until an interaction, a measurement, makes it concrete.
Niels Bohr had that famous quote about it, didn't he?
He did. No phenomenon is a phenomenon until it is an observed phenomenon, which is a pretty radical statement.
It really is. It implies that observation isn't just passive reporting of what's there. It's actually involved in bringing that reality about.
Exactly. It suggests our interaction with the world at this fundamental level might be participatory. We're not just spectators.
Which, okay, brings us back to that initial thought. Maybe slightly less crazy now. That idea of a rendered universe.
You can see the parallel, can't you?
Yeah. If things only become definite, only get rendered when we observe them. It sounds a bit like how a video game saves processing power by only fully drawing what's in the player's view.
The analogy is definitely tempting, and many people make that connection. If the universe operates on probabilities until interaction, you can see how that might mirror resource optimization in, say, a simulation.
Right.
But, and this is a crucial but, the double slit experiment doesn't prove we're in a simulation. It doesn't prove reality isn't real.
Okay, fair enough. But it does suggest.
It suggests that reality at its most fundamental level is, well, stranger than we think. Perhaps more information-based, more dependent on interaction and observation than our classical, everyday intuition allows for.
So not necessarily a glitch in the matrix, but definitely a sign that the operating system of the universe is weird.
That's a good way to put it. It certainly challenges the old billiard ball view of the universe. Things aren't just solid objects bouncing around deterministically. It's more fluid, more about potentiality.
Which makes Einstein's reaction completely understandable. He really didn't like this quantum stuff, did he?
Not at all. Einstein was deeply, profoundly uncomfortable with it. The randomness, the uncertainty, this apparent role of the observer, it all clashed with his belief in an objective, predictable, underlying reality.
He wanted things to be real whether we looked or not.
Precisely. He famously expressed this with the line,
God does not play dice with the universe.
exactly. He felt quantum mechanics, as it was being described, must be incomplete. There had to be some deeper layer, some hidden variables that would explain everything in a deterministic way if only we could find them.
It's such a fundamental disagreement between giants. Bohr's reply was pretty pointed too, wasn't it?
It was. Bohr apparently retorted, Einstein, stop telling God what to do, which really highlights the philosophical chasm between them. Bohr was saying, essentially, we have to accept the weirdness the experiments show us, even if it defies common sense.
And I mean, subsequent experiments like testing Bill's theorem, they haven't exactly vindicated Einstein's hidden variables idea, have they?
No, generally speaking, experiments have consistently backed the predictions of standard quantum mechanics, strangeness and all, over the types of local hidden variable theories Einstein envisioned. The universe really does seem to be non-local and probabilistic at its core.
Okay, so we're left with this wave-particle duality. Things can be waves or particles. And this observer effect, where looking forces a choice. What's the big takeaway from that?
I think the biggest takeaway is the intimate connection between the observer and the observed. Measurement isn't passive. It seems to be an active participation in defining reality, at least at that quantum scale.
It forces the universe to show one face or the other.
Right. And the waves-particle duality itself tells us these quantum entities don't have one fixed nature. Their identity, or at least their behavior, seems to be contextual. It depends on how we set up the experiment, how we choose to interact with them.
Does reality require us to look for it to become definite? It's such a strange question.
It is, and it leads us back maybe to that simulation idea, not as proof, but as a metaphor.
Yeah, like our observation is the rendering command, triggering the universe to load the specifics. Again, not saying it is that, but it maps onto the observation problem in an interesting way.
It's a compelling parallel to consider, especially if you're thinking about how attention and focus work, maybe even in our own lives. But scientifically, the focus remains on understanding the quantum rules themselves.
And this experiment, it's not just some old historical curiosity,
Yeah.
right? It's still fundamental.
Oh, absolutely fundamental. It's taught in physics everywhere because it's such a clear, stark demonstration of quantum principles. It shows the probabilistic nature of reality. It challenges cause and effect. It makes you question what knowledge even is at that level.
And the kicker is, if you set up the detector, watch the photon go through one slit, and then you remove the detector.
The interference pattern comes back.
It just snaps back to being a wave the moment you stop looking.
As far as the results show, yes. Remove the witch path information, and the wave behavior, the interference, returns. It really hammers home the apparent role of observation, or maybe more accurately, information.
Wow. So at the end of the day, what is light? What are these quantum things? A wave, a particle.
Both. Neither. Something else entirely that just manifests as one or the other depending on how we probe it. That's still, in many ways, the deep question the double-slit experiment leaves us with.
It's definitely a lot to chew on. This whole deep dive really just underscores how bizarre and counterintuitive the quantum world is. Reality isn't as straightforward as it looks, and observation seems, well, critical somehow.
Exactly. It forces us to confront the limits of our everyday intuition and accept that the fundamental workings of the universe might follow rules that are profoundly strange from our perspective.
And as we explore all sorts of ideas on this channel, thinking about optimizing our lives, our health, these kinds of fundamental questions about reality, about awareness, they just add another layer, don't they? It makes you wonder.
It certainly does, and maybe for everyone listening, the question becomes, if observation plays this role at the quantum level, what does that imply about the power of our attention, our focus, in the world we experience every day? Could there be more to it?
Definitely something to ponder. Well, if you enjoyed this trip down the quantum rabbit hole, make sure you're subscribed here for more deep dives into, well, the nature of things. We explore these kinds of big questions all the time. You can also find more detailed notes and discussions over at mdtalk.substack.com.
And perhaps just asking these questions, challenging our assumptions about reality, whether it feels like a simulation or just fundamentally weird. Maybe that's a crucial part of engaging with the mystery itself.
Couldn't agree more. Thanks for joining us for this deep dive.